Okay, before we start the video, I want you all to observe these three pieces of code. This is the same piece of code written by the same AI for the same task. This is version 1. Very basic, no error handling at all. This is version 2. Added some validation, have some proper structure. Whereas this is version 3. If you observe carefully, it's production ready with document strings, type hints, edge case handling, and logging. No human touch in the code between the versions. The AI critiqued its own work and improved it. In this case, 3 times. This is reflection pattern, the first and the most powerful agentic design pattern. And today, you're going to build it from scratch. I'm Prashant Nair. This is part 1 of Agentic Design Patterns. Let's go for it. Quick context. This is a 4-part series of Agentic Design Patterns, the architectural patterns that makes AI agents actually work in production. Part 1 is reflection, an agent that improves its own output through self-critique. Part 2 will be supervisor, one agent orchestrating a team. Part 3, round robin with reflection, agents collaborating and critiquing each other. Part 4 is guardrails, safety and validation for production agents. If you all have watched my previous video in this series, you already know LangChain and LangGraph. Today we will use LangGraph to implement reflection. If you haven't watched those, the links are in description, but you can follow along either way. So here's the idea. You given an AI a task. It generates a first draft. Instead of shipping that first draft, you have a second perspective, a critique that evaluates the output, identifies what's wrong, and provides specific feedback. The original generator takes that feedback, revises its work, and produces a better version. The critique evaluates again, and this loop continues until the output meets a quality threshold, or maybe maximum number of iterations. Think about how humans work, everybody. The writer doesn't publish their work after first draft. They write, they reread, they revise. The developer doesn't ship the first version of code as it is. They write, they review, they refactor. In similar way, reflection gives AI the same capability. The AI becomes its own editor, its own code reviewer, and its own, I can say, quality checker. So ideally speaking, if you see my slide right now, it's a loop. Generate, critique, improve, critique, improve, critique, until and unless you either approve it or maybe we max out the iterations of improvement. 2 key decisions that you need to consider whenever you're using reflection as a technique. Number 1, what does the critique evaluate? Remember, this is where you need to be smart while writing your prompt. This is, technically speaking, your quality rubric. For code, the ideal rubric would be correctness, readability, error handling, and documentation. Often people neglect documentation. You shouldn't. For writing, we need to focus on clarity, we need to focus on structure, we need to focus on tone. So depending upon the work, you will decide the rubric. That's the first decision you need to take. Second decision that you need to take before you start implementing reflection, I would say, is when does it stop? One of the issue of reflection is there's a high possibility that the system might overthink again and again like an infinite while loop. So there should be something that can stop that infinity loop. And that's where we set up maximum iteration count, everybody. And also, ideally speaking, ensure you write your critique code in such a way, ensure you add the quality critique in such a way that we have some measured way to figure out the quality of the code or whatever it is. So the thing that you can think of reflection here is reflection is giving AI the ability to do a second draft. It's that simple, everybody. So here's what we are building. Two nodes, generator node and the critic node. The generator writes the code, the critic reviews it. A conditional edge connects them. If critic says needs improvement, the output goes back to the generator with the feedback. If the critic says approved, it will simply exit with the final output generated. So this loop that I have shown here, this is back and forth between generator and critique. And this exactly is reflection pattern. It's deceptively simple in structure, but incredibly powerful in output quality. So let's see things in action, everybody. I have just prepared a simple reflection pattern example. Of course, here my goal is what? I want to build an AI code reviewer that writes Python code, critiques it against quality rubric, and iteratively improves it when it meets production standards. Everybody, please understand this fact. So, reflection is giving the AI the ability to do second draft, like I said. Just like developers writes, reviews, and refactors, here the AI is the one responsible to generate, critique, and improve. This entire tech stack is designed using LangGraph, LangChain, and OpenAI GPT-4 Mini. So first thing first, obviously what we are going to do is, let me just connect my system. First thing first, we will be doing an installation of LangChain, LangChain Core, LangChain OpenAI, LangGraph, GrandALF for the comments part basically, which we will eventually see. More core, what we require is LangChain and LangGraph. Let me just do the installation. Perfect. Once the installation is completed, the very next step that you are going to do is you are going to configure OpenAI. So here we have set up the OpenAI key in the secrets, by the way. So in the secrets, I have created a variable called OpenAI underscore API underscore key, whose value I have set in the secret, and that's something I am calling using google.colab user data. So I'll just call this to ensure my keys are set for the program. Now the time comes. See, whenever you're working on LangGraph, the primary secret is you prepare a proper state object. The state tracks everything across iterations, everybody, in this scenario. What are the things that I have added here? I added the task. So whatever task I'm giving AI to code, that task will be stored here. The current version of the code, whatever code is generated by the generator. The code history, whatever was generated by generator, all iterations, everything will be stored in list of strings. The feedback history, so whatever feedback is created by critique, even that is stored. Iteration limit. Now here current number of iteration basically. So this is nothing to track the number of iterations happened till now. The max allowed iterations. Like I said, there's a high chance reflection may go infinite. So to deal with that situation, we can set up maximum iterations that I have set up here. And of course, approved. So this is something that critique will decide whether approved will be true or false. If approved is true means the final code will be dispatched. If approved is false means the improvement will happen. So here we are going to set up the state schema, reflection state. So here what we have done, state schema has been defined, max iteration we have set is 2, 3. You can increase this when you will get this notebook. Next, as you can see here, we are going to define the generator and the critique. So generator is the one responsible to write or rewrite the code based on the task and any feedback. Understand one point. The first iteration is writing code based on the given task. The subsequent iteration will be writing the code based on the feedback provided by the critique. That's the catch here, everyone. And whereas what is the role of critique? I can say it reviews the code against the specific quality rubric and either approves or provides some actionable feedback. Now remember, as a GenAI developer or as an agentic AI engineer, your challenge is to define rubrics. Rubrics is the secret for any good successful system. Now here, my goal is to code. So for code, we are going to prepare some definite rubrics. I have tried to explain that in the critique section. I want you all to focus on that section well. Okay. However, coming back here, I have just enabled my LLM GPT-4o mini. Temperature I have set to 0.3. Anything between 0 to 0.4 would be a good option. You need to give little creativity, but not over creativity, especially when you're doing coding related tasks. And yeah, one more thing, generally people ask me a question here, I mean, based on my class experience and all, that is GPT-4o mini a good option for coding perspective? So yes, see, if you check the OpenAI website, there are models specialized for coding. You can use Codex and other stuff. So I will encourage you can use that here. In fact, what you can do is you can use GPT Codex here, and for critique maybe something better, maybe like Gemini Codex or something similar. Now as you can see in the generator code, what I'm doing, like I said earlier, if I am in the first iteration, I am specifying the task. So this task is stored in the state of task, state object. And what I'm doing here, I am telling the system to write a clean working Python code, include the function and brief example on how to use it. If this is not first iteration, then what I'm saying, check the last feedback that you have received from the state, basically from the critique. And this is the prompt. Your previous code was reviewed and needs improvement. This was the given task. This was your previous code. And this is the feedback given by the reviewer, which is this object. Please rewrite the code addressing all the feedback points. Keep what is good. Fix what is flagged. This is very important. I don't want the good stuff to get bad again, right? So keep what is good. Fix what is flagged. And here you can see the response object, LLM object. So the system message is, you are a senior Python developer. Write clean production quality code. When improving code based on feedback, address every point specifically. Always include type hints, doc strings, error handling, and usage example. Return only the code, no explanations outside the code block. So this is ensuring that I am specifying a specific output format and expectation in the output. So this will actually generate the code, whatever the code generated, I am putting it in the code, and this code I am printing also. I'm just printing first 500 lines, not lines, characters. And here, what I'm doing here is I am returning the state object. I am actually editing so I am adding the code, whatever is generated by the generator. Code history also, I am appending the code, and I am increasing the iteration. Remember, every time iteration will be increased. Okay, you can see here, this is the incremental area of iteration. That's it about generator, everybody. Now let's talk about the critique. The critique is responsible to review and evaluate the code. So here, as you can see here, once again, so remember, whenever you create any function, that should have the state object, then only it can access the state, obviously. So here, defining rubrics, that matters. Always say, see, whenever you're evaluating something, anything in the world of GenAI or agentic AI, rule number one, be clear with rubrics. Have a word with your domain expert. Understand the domain and then define rubrics, measurable rubrics. Measurable. Remember the SMART strategy that we may have always learned? Specific, measurable, those things. So, what I have done here, for critique, you are a strict but fair senior code reviewer. Evaluate the code against this rubric. So, rubric is what? I try to make it as production ready as possible for you all. So, here as you can see what I did, correctness, where I'm telling the system, does it solve the task correctly? Error handling. Does it handle edge cases like empty input, invalid data, missing fields? Now you can add multiple more things here, though LLM will be smart to understand what all things you need to consider, but still you can specify it. And this is like, now comes the fact where I will require a developer who can explain me what all things I need to add here. Think in that perspective. Or maybe a tester who has experience in creating test cases for the scenarios. They are my domain experts who will help me to write this second point very well. Third is type hints. Are all function parameters and return types annotated? Documentation. Does it have clear doc strings and comments? Code quality. clean variable names, dry principles, DRY, hope you remember. Proper structure, edge cases, does it handle boundary conditions? So right now in this demo, I have added these 6 rubrics for you all. You can add as much rubrics you want, but ensure it is specific, discrete, numerical, measurable. Don't over add something or don't add any vague rubrics. If you add a vague rubrics, like you say, if you give garbage to AI, AI will give garbage only. If you give data to AI, AI will give data only. But if you give intelligence to AI, AI will return intelligence. So ensure you know what you're doing here. So as you can see here, your response must start with exactly one, that is approved or need improvements. So approved if the code meets all criteria at the production level, needs improvement if any criteria is not fully sent. So remember what I'm doing. After the verdict, provide the score between 1 to 1 for each criterion. Specific actionable feedback for any score below 8. What was done well? Acknowledge those things also. Be demanding but fair. Only approve truly production ready code. That's it. So the secret of reflection pattern is the rubrics that you refine in Critic. That is the primary secret, and that's where you need to involve your domain expert, or maybe you should have good knowledge on your specific domain and the task that you are building. So as usual, same human message. As you can see, review the code, the task is given, the code is given, iteration is been set, and total iteration available is also set. Feedback maintained here, approved status maintained here. Status is if approved, else needs improvement. This is just printing. We are just printing the status by the way in the verdict. And then everything is stored back in the state. So feedback history, we are storing it here. We are appending basically the current feedback. Approved, we are just giving the approved. So in a nutshell here, this line of code is responsible to build your generator and critique. Next, what we are doing is we are building a reflection graph. Like I said, our graph has 2 nodes, the generator node and the critique node, and they are connected by a conditional edge. Rule is simple. If the code is approved, end it. If the code is not approved and iterations are remaining, back to generator. If max iterations reached, end it. It's that simple. So what I've done here is I created a function called should continue, which will act as my conditional edge later, wherein I'm saying if state of approved, in that case code approved at iteration so and so, exiting loop, and return end. Return end means this will be my end node basically. If state of iteration is greater than state of max iteration, still we are exiting the loop, return end. Otherwise, sending back to generator, improve. That's the default condition. Now we are building the graph, so we created a workflow object. We are adding the generator and critique. So generate code is the function which I created above. So function name was generate code. This will be my generator. Similarly, we have function critique code. This will be my critique. So I have given the node name as generator and critique respectively with the function which is attached to it. I set the entry point as generator, and generator always goes to critique. That's what I'm taking care. So generator output is input to critique, and this is where I am adding a conditional edge from critique. It should go to should continue. Should continue is the function which I created here, everybody. So if it is improve, go to generator, otherwise go to end. So this is my complete workflow. I'll just execute this, and to visualize the workflow, you can see here what happened. Start variable created, goes to generator, generator to critique, if improve, back to generator critique, if improve, back to generator critique, if improve, back to generator critique. This is infinite. To deal with infinity, we have taken care of max iteration, everybody, which is there in our conditional term. So here I have given a very Python simple task. So Python function to generate called generate order report that takes list of dictionaries, each representing an e-commerce order with keys, order ID, product, quantity, price, status. Status I have mentioned, pending, ship, delivered, cancel. Returns a dictionary summary object containing total revenue, total orders, average order value, order by status, stock product, cancellation rate. So the task is to create a function. So what I'm doing here, everybody, in the graph using invoke method, I am defining the task. Code initially will be obviously empty, code history will be empty, feedback will be empty, iteration I'm setting it to 0, max iteration I'm setting it to 3. Above I have given that max iteration 3. Approved for now, I'm setting it to false. So when I start this, the task is given, generator is started its work. As you can see, the execution is in progress. So this will take some time. It will bring the code. Once the code is generated, the code is then given to the critique. The critique will critique the code, and based on that, you can see here, this is the code generated. Now critique is reviewing in iteration 1. Let's see how the code is built. Let's see the critique's feedback, by the way. The verdict given by critique is it needs improvement because correctness score is 9, error handling is 8, type hints is 9, documentation 8, quality 8, edge case is 7. So because of that 7, I believe the problem happened. So now generator 2, iteration 2. Let's see how it works. Okay, he created something. Let's see the review. And remember, whatever code is generated here, all those code are saved in the list object of the state column. So yeah, you can see the feedback of the state 2. Edge cases score improved. Earlier it was 7, now it's 8, by the way. But I have given something perfect, right? I want everything 9. So obviously, I guess it will max out, I believe. Let's see. Let's see what is the iteration 3. Okay. As you can see here, correctness came to 10, error handling 9, type hints 10, documentation 10, code quality 9, edge cases 9. Everything is above 8. That's the reason why the code is approved at the third iteration. So remember, when you will be executing this code, maybe you will see the max iteration may max out. Because see, we cannot expect every time the LLM will give the same output, right? Here in my case, it gave it. So you can see reflection actually worked well. The critique has finally approved the code, and the final code you can actually see here. So by the way, you can see all the 3 codes. I'll not execute this in front of you for now. I will execute the final code. So let me execute first of all, let me execute the iteration 1. So this was iteration 1, though we saw it above. You can see the improvement was superb. So in first 2 iterations, it said need improvement. In the third one, it said approved. Okay, and you can actually see the final code also, by the way. Okay, overall, in this section, what was the primary observation? The observation was AI is evaluating its own generation, and based on a finite measurable rubric, the AI itself is deciding whether he needs to improve or whether to approve. This is the classic example of reflection, everybody. Now the question comes, where reflection works. So I would say use reflection when the output quality matters more than speed. This is important because, see, if you're expecting faster output, don't use reflection. That would be my personal recommendation for you, because it will take time. And yes, cost will be more. Every LLM code is chargeable. And every time you're passing a lot of feedback with the code, token utilization will be more. That's there. So ideally speaking, use reflection when the output quality matters more than speed. The task is iterative, and based on the iteration only, the things will improve. So you need to have a clear evaluation criteria that you can express in the prompt. If you don't have a clear evaluation criteria, that's where things go south. Second thing is, don't use reflection when the task is binary. At times in some design patterns, some beginners code, I always observe that if the task is binary, they are still using reflection. Don't use it. See, latency is critical and you can't afford multiple LLM calls. Okay, so usually for binary task and all, if the answer is single answer, you don't need a reflection. If the answer is wrong, it's wrong. Otherwise, it's right. It's that simple. Don't use reflection when latency is critical. Latency is critical. You need to spend time. It's more like a batch activity. And never ever use reflection if you yourself are not clear about the rubric. If you yourself doesn't know the evaluation criteria, never use reflection. Also consider the cost factor, by the way, because each iteration is an additional LLM call, 2 calls per loop, like generator 1 call, critic 1 call. So 3 iterations means ideally 6 LLM calls for one task. For high volume, low value task, it might not worth it. For high outputs, high value outputs like production code or client facing content, it's absolutely worth it. So that's reflection, everybody. The first agentic design pattern, the simplest, most intuitive, and one of the most powerful technique. Do not underestimate the power of reflection, everybody. Part 2 of this series, we are going to discuss about the supervisor pattern, the one agent that orchestrates the team of specialists. Think of it as a manager of an AI team. It decides who does what, reviews their work, and coordinates the output. That's the next video that I'm going to build. Subscribe so you don't miss it. The notebook for today's demo is in the description. Run it yourself, change the task, and watch the AI improve its own work. I'll see you all in part 2. Bye-bye.